Hey guys, here's just a quick little assistance with solving these problems, maybe to help recap what's in the reading so that you guys are equipped to handle the questions. Um, the important thing that you have to keep in mind with two-dimensional motion is that just like with our forces, while we can say that um, each dimension is independent, we can do the same thing with our motion. So there's kind of two examples that they work through, but they work essentially the same way, and that is that you have to kind of break things up into horizontal and vertical motion. Once you have everything broken up into vertical and horizontal motion, then you solve just like you would with any one-dimensional situation. Now, for projectiles, the one thing that is always going to be the case if we're talking about free fall is that in free fall, our acceleration in the vertical, well, that AY, is just going to be equal to the acceleration due to gravity. Meanwhile, since gravity only acts in a vertical direction, and in this kind of example, we're looking at a coordinate system that has vertical up and down, horizontal right and left, we also know that in the horizontal, we will not have any acceleration. So our acceleration will be zero in the horizontal direction. That means that horizontally, my motion is going to be just following constant velocity motion, while in the vertical, my velocity, displacement, all of those things will follow projectile motion or free fall motion. So if I want to know how far horizontally this is going to go, well, I know that the change in my position is just going to be equal to my horizontal velocity times time. And then in the vertical direction, since in this dropped example or horizontally launched example is moving only horizontally before, in these examples, my initial velocity in the horizontal is zero. So I can basically just say change in my vertical position is equal to 1/2 ay t squared. The one thing that will definitely be the same for both, since we're talking about the motion, is that the time term on the right is going to match the time term on the left for any interval that we're looking at. Okay, so once we break it down, just keep in mind we can follow these things just like any motion in one dimension. This curved path is really just a result of the observing both of those motions happen at the same time. Now, if we're not talking about something that's dropped and we're looking at something that's launched at an angle, we are still able to break things up in the vertical and the horizontal and solve for that motion. And as before, we're really just looking at our horizontal motion being constant velocity motion, and our vertical motion being the same as the motion of something that is launched upwards, slows down as it gets to the top, comes back down, speeds up as it goes down. So once we have those things broken up and we recognize those things like my horizontal acceleration is zero while my vertical acceleration is gravity, you're essentially solving these two things as two separate problems. Normally, when we talk about the projectiles, the thing that we have to focus on is how long it's going to be in the air. And really, if we're talking about how long is it going to be in the air before it hits the ground, then that's going to come from my vertical motion. So I can just go up and down there. Now, one thing to keep in mind with that equation, that looks like um, y final, oh, this is getting ugly, is equal to y initial plus vy, okay, y initial t plus 1/2 ay t squared. Is that if I've got a squared, an unraised exponent, and just a numerical term together, we can solve that using the quadratic equation. Basically, in terms of the coefficients, what we would keep in mind is that essentially, if I can arrange this so it's all equal to 0, like let's say we say my final position is 0 when I hit the ground, then for that quadratic equation, this 1/2 a essentially is your a term. This is going to be your b term, and this is going to be your c term, and we can use the equation for t. T is going to be equal to negative b plus or minus, this is not working that well, plus or minus 1 b squared minus 4ac all over 2a. Hopefully that'll get you far enough along with the reading. I just thought I'd add this in as a little bit of extra support.